Good morning and welcome to another lesson on datas and errors. It seems to me we're having a bit of fun with this, as in we're struggling to really come to terms with it. The whole idea is the fact that we must lose the idea from our mind that everything we collect in a science lab or whenever we're doing measurements is accurate. And as we know, that is not quite correct. So let's try to rethink that, lose that from our mind. No matter how good we are, no matter how clever we are, no matter how accurate we think we are, we're always going to make mistakes. And I've told you about random and systematic errors before. You might like to go and revisit that at some stage. Don't forget, this is why you're actually asked to do in any science activity multiple trials. And the purpose of that is to try to get you to a stage where you will be close to where the real value is. And that's why we must use the average. Now, some of us have also forgotten that when we do a chart of this, we graph the average because that gives us an approximation of where the real value could be. Now, we're going to look at that a little bit more closely now. To try to get rid of these errors that creep into our measurement. So when we're doing this, let's say if I do 6 values, and I've done them here in the hypothetical situation where I've got a certain value regardless of what it is of A. I've got 1 incidence there, 2 incidents at B, 2 incidents at C, and 1 incident at D. And there is a bit of a gap between them. So when we find the average, what we're trying to actually say is that our total sense of is somewhere in the middle, is somewhere in here, between B and C, is where our number is most likely to be. Now, the more times we go and get numbers, now I've done 6 here, so I did 6 trials. So if I'd done 10, I might find there might be a little bit more spread, but I might have more numbers here. And that's just a stronger indication that this area is where the real value will be. So whenever we're doing anything after we've calculated the average, this is the one we concentrate on. Right? Because this is our best guess at what the real value is. And that's most important. And that's why we don't do graphs with all the rest of these. We're just cluttering up our mind again. So what we're actually saying is this is the average here, this value with the red dot. Then the real value is going to be a little bit below or a little bit above. We know it's in there somewhere, but we're not actually sure or certain, would probably be a better word, of actually where in that range it is. Okay, so we're saying it could be there or there. And that's what these error bars are all about. Because they show us how far below or how far above the value could be. But it does put the average value in the middle, and that's why we use the average, and that's why we do not have to show the trials, because effectively the trials are shown by our error bars. Now, in real terms, because when we do any sort of graph of this, we are looking at 2 things. We are trying to control something in our independent variable down the bottom, but realistically, the value we are assuming or using in our independent value is again open to interpretation. So it will be a little bit below and a little bit above. So we would have this, an error bar this way. Now, when we measure these things in our dependent variable, we also know there is going to be a range. Here is the average value, and there will be a range above and below it as well. So this gives us, instead of just a 2-dimensional thing, this gives us a bit of a box around it, which when you saw the Desmos video, you saw that Mr. Mum talked about a window of uncertainty. This looks like an old window. And this anywhere in here, in here, in here, in here, in here, somewhere in this window is actually where the real number is. Now this box or window of uncertainty is around every data point. I've only put one data point in at the moment. But our windows are everywhere, so our real numbers go in here. Somewhere in that region will be our real number. So if we put 4 data points in, and I only put 4 in to really stop us going crazy, we can see that somewhere in this range is going to be where our real values are. And this is why we use a trend line. Because the trend line follows the data points, but it also takes into account the areas around, the windows of uncertainty around the data points, each data point. And that's why our graph, our trend line, does not always go through each of the data points. It doesn't necessarily have to go through there. But what it must do is actually go through the window of uncertainty. So our trend line can come up through the top like that, or it can come up through the bottom like that, or it can be a straight line that starts on one side and goes up the other. It does not, and I repeat, does not have to come and touch or go through any one of the data points, the average data points. All right? Some people think the line must go through these points because the points are accurate, and we've established they're not. So what the line can do, it can start off at the top and go like that through, and it can go something like this. So somewhere in there is the real trend line, but the trend lines are simply going up, left to right, and that's what our trend line would show. All right, more about that as we see some of the patterns that observe.